I am Taylor Brown, and this is Lab 5, Exercise 1. So, for Exercise 1, we just have a 12-volt supplied to a 470 ohm resistor and a diode in series. So, I have that right here. I have my resistor and my diode, and then I'm using my power supply to generate 12 volts. And when I do that, when I measure the voltage across the diode, I get 748 millivolts, and I calculated 674 millivolts. All right, now I'm measuring the current through the diode. So I've broken my circuit here, and I have my multimeter probes right here. I'm still supplying 12 volts to this circuit, and I'm getting an output of 24.66 or 65 milliamps, and I calculated 23.62 milliamps. Now I'm just finding the voltage that I need to supply to my circuit in order for the current through the diode to be 10 milliamps. So I've just been adjusting my function generator, and in order to get it close to 10 milliamps, the voltage would have to be 5.4 volts, and my calculated was 5.475 volts. All right, now this is exercise 2, where we have a 100 ohm resistor in series with a Zener diode, and we're just going to be measuring the voltage and the current across the resistor and the diode. So here I have my circuit constructed, and I'm generating 10 volts to my circuit. And when I do that, I get a voltage reading across the resistor of 5.164 volts, and my simulated value was 5.2582 volts. All right, now for the voltage across the diode, I'm getting a reading of 4.889 volts, and my simulated value was 4.7418 volts. All right, now I broke the circuit, and I'm measuring the current through my resistor, and I'm getting a measurement of 52.66 milliamps, and my simulated was 52.5824 milliamps. All right, now since this circuit is just a simple series circuit, the current is the same everywhere throughout it. But I'm also measuring the current again across the diode, and I'm getting pretty much the same thing as before, 52.66 milliamps, and I simulated 52.5824 milliamps. All right, now I'm on exercise 3, and right now I'm measuring for when the Vin is 8 volts to my circuit. I have my multimeter connected to measure the V out, which is from this node right here to ground, and my multimeter is giving me a V out of 5.733 volts, and my simulation said that it would be 5.59 volts. When my V in is 7 volts, I'm getting a measurement of a V out of 5.687 volts, and my simulated value for when the V in was 7 volts is 5.5669 volts. Now we're looking at when the V in is 6 volts to my circuit. I'm getting a V out measurement of 5.619 volts, and my simulation gave me a voltage out of 5.5112 volts. For a 5 volt V in to my circuit, I get a V out of 5.036, and I calculated it to be 5 volts. For a V in of 4 volts to my circuit, I'm reading a V out of 4.038 volts. And I've been saying that I calculated these, but these are just simulated values. So my simulated value is 4 volts. For a 3 volt V in to my circuit, I'm getting a V out of 3.04 volts, and my simulated value is 3 volts. When my V in is 2 volts to my circuit, I'm measuring a V out of 2.059 volts, and I simulated it to be 2 volts. When my V in is 1 volt, I'm measuring my V out to be 1.047 volts, and my simulated value is 1 volt. when my VIN is 0 volts, I'm measuring a very small negative V out, which is negative 4.7 millivolts. But in my simulation, it was 24.9 microvolts. So it is off in terms of scaling, but they're both really small values. All right, now I'm at the part of the DC sweep where I'm analyzing negative VINs. So in order to create a negative VIN with my power supply, I flipped the polarity of the wires that I had in my circuit. And then, so technically I'm supplying 1 volt, but since I've switched the wires around, now it's negative 1 volt to the circuit. And I'm measuring a V out of negative 581 millivolts. And in my simulation, it gave me negative 511 millivolts. Now for a negative 2 VIN to my circuit, I'm measuring a V out of negative 639 millivolts. And my simulation told me that it would be about negative 566.9 millivolts. Now for a VIN of negative 3 volts to my circuit, I'm getting a V out of negative 663 millivolts. And my simulation gave me a V out of negative 593 millivolts. Now we're looking at a VN of negative 4 volts to our circuit, and I'm getting a V out of negative 679 millivolts. And my simulation gave me a V out of negative 611 millivolts. And now for our last value of a VIN of negative 5 volts, I'm getting a V out of negative 689 millivolts. And my simulation gave me a value of negative 624 millivolts. So these are all of my values for the DC sweep for exercise 3. All right, now we are on exercise 4. And what I just did was find the correct voltage output with the correct frequency from my function generator. Since it's generating so slowly, I had to zoom out quite a bit for the time scale, and it was pretty much trial and error for getting the right amplitude. But now I'm getting a voltage from peak to peak of 19.6 with a frequency of 1 hertz. So now I will supply this to my circuit. All right, now this is exercise 4. I have my circuit right here, and I'm using the same output from my function generator as I showed before. And now I'm measuring the voltage across my green LED. So here, I'm measuring a max of 2.8 volts, so the amplitude is 2.8 volts, and then my simulated was 2.089 volts. All right, now I'm getting 6.4 volts as my voltage across my red 1 diode.
Who was next to you?
So it said 6.8 earlier, but now it's saying 6.4. So for the voltage of my red diode, I'm getting 6.4. My simulated was 6.489. All right, now I'm measuring the voltage across my red diode. I just had to switch the order of my red diode and my regular diode. I accidentally had this red LED to ground and then the diode in front of it. So I just switched those. And now I'm getting a voltage reading of 5.6. It was just giving me 6 volts, so I'll wait a second and see if it comes back. But my simulated value was 6.77 volts. All right, now I'm measuring the voltage across my first Zener diode, so this one right here. I'm getting a max voltage of 4.4 volts across it, and my simulated value is 4.6824 volts. All right, now for the last part of exercise 4, I'm measuring the voltage across my second Zener diode. I'm getting a maximum value of 1.2 volts, and my simulated value was 1.25 volts.